All right, everybody, welcome to Air Science. So it's time to do a lab that's going to make us use our heads with both humidity, all the humidity stuff we learned, relative humidities and dew points. You actually don't have to calculate any, so I guess that's good news if you're a little stumped on that. But you should still figure that out. We're going to use some of the humidity stuff we learned, and we're going to have to draw ISO lines on the map. All right, so the purpose of the lab is going to be to figure out what happens when moving air, wind, comes at an elevation of some type, like a mountain, and rises up that mountain. The lab we're going to do is going to look at that on Hawaii. Our examples here, this is just kind of a generic example of what happens, like say in the mountains off to the west of the United States. But we can also look at it here on the Tug Hill Plateau. This is what it's going to look like this weekend. I'm taping this on Friday. That snow day we had for the COVID vaccines. But by the time that we all actually work on this on Monday, probably by the time you watch it, this will have already happened. So what's the deal? Why is there like this chunk of heavy snowfall there, not over here? And from the same system off a different lake down here, it's not that high, but up there it is. So that's what we're going to try to unwrap here, and it really encapsulates. This is got a little. It's a little bit heady. This is going to be like combining a lot of the things we've learned all into one idea. So it can be a little bit of review, a little bit of new, but it's like a melding together of different ideas. All right, so let's do it. You're probably going to want to zoom at a couple of points. Your call. But down here, let's call this the Pacific Ocean. Again, this is going to be what goes on out on the west coast of the United States as you get up into those mountain ranges. So if we've got wind coming off of the Pacific Ocean, and we go back to remembering everything we know about air masses, we would know that this is going to be maritime, M. Because if you're in the southern part, maybe it's maritime tropical coming up from the south, or maritime polar certainly come down over the like the Cascades and the northern Rockies. But M, just for maritime. Polar or tropical would just be the temperature. No matter what, it's maritime air because it's coming from the ocean. So we've got wet air coming at a mountain range here, and what happens as it hits? All right, so it gets forced up. It's got to climb. So what I'm going to do is like a numbered list of steps. Only I'm going to number them from the bottom going up because that's going to go in order, like in terms of like the order of events that things happen in. All right, so first one, as I've said, why did I jump like that? Air rises. It's got nowhere to go but up. All right, as you go up, pressure gets to be less and less and less. If you live, let's say this circle is your head. You don't have to put these on there. I'm going to erase them. If you live right there, if that's your head, you've got the weight of the atmosphere from the top of your head all the way up to the top of the atmosphere squished down on you. It's heavy. It's a burden to carry this atmosphere around, even though you don't really feel it. But if you live way up high in the mountains, now you've got a lot less atmosphere on top of you. When I lived in Colorado, we went to this thing outside of Denver, and there was a sign, and it said, right now, I don't remember the exact number, but right now, something like 50, 60% of the atmosphere is below your feet. Most of the air is below the elevation that some of those cities are out there. That's why Denver has a big advantage in sports at home. It's easier to hit home runs there. There's less atmosphere for the ball to travel through. If a team comes up from the coast, if the Carolina Panthers go up there to play football, and you're a big, huge lineman, and suddenly you have way less air, that's a disadvantage. Whereas if you train up there, you're used to it. Bikers train up there like crazy. The like Tour de France, serious bikers. When I moved there, it was difficult. Like I couldn't carry the couch up the set of stairs without like just having to sit and rest for a while to get some air back in my lungs. You get used to it, but that's the deal. So if there's less and less and less atmosphere, there's less and less pressure on it. Let's picture it like a balloon. If I had a balloon or a bag of potato chips that was sealed, and I had it around here, and then I start going up to where there's less atmosphere pushing on it, what's going to happen to that balloon or that bag of chips? It's got less atmosphere squishing on it, so it's going to have the ability to get larger and larger and larger. This really is a thing that happens. I worked in like a food co-op. We would open up the big boxes that the bags of chips came in, and they'd all come like popping out. They'd be fully inflated like footballs, like you couldn't squeeze them at all. So when things like air, and I know it's like okay, the balloon example is easy. You take a balloon, you go up, there's less pressure, so the balloon gets bigger. But this happens to like air, just loose air in the atmosphere too. As it goes up, there's less squishing on it, so it can expand. It's not great. There we go. Sorry for that like auto weird format thing that's happening there. So it rises and it expands, and we keep going up as a function of it expanding. Without getting into the molecular nature of air, which this video, I have a feeling, is already going to get long. If you take the air that's in between my hands right now, it's got a whole bunch of molecules. They're jiggling around, they're moving. If you were to expand them out, they are going to not be banging into each other as much and they slow down. Or you can go take chemistry, figure out like ideal gas laws and all that, then come back. But if you want to take a shortcut, say, hey, give it to me straight, buddy. When air expands, it cools. Now, usually I give a homework, which is go find somebody that took earth science already in the hallway during break and ask them what happens when air rises. And if they don't say expands and cools like that, I want to know who it was because I would make the students in class say this like 1,000 times. Now, this isn't a typical year. These aren't typical classes. They're frustrating for all of us in many ways. So I can't do that. But let me say that it's like an absolutely fundamental key idea in meteorology that when air rises, it expands and cools. That's going to allow all this other stuff to happen. Because when it cools, just like, and hopefully you did the lab with humidity when I was at my house with the aluminum can, I put an ice cube in and I stirred it until the can got cold enough, cools, to make the air hit the dew points. That's going to be the next step. 4, air reaches dew points. It'll cool and cool and cool until it hits the dew points. And at that moment, what dew point is, like the definition of dew points, we get clouds. So like these next steps are kind of all simultaneous. 5, you get condensation. In fact, move it over here and just do it all. I'll stop numbering. Condensation. Remember, that's what dew point means. The dew point is the temperature at which condensation occurs. So when we cool enough to get to the dew point, condensation occurs. In that lab, I showed you, I rubbed it, and you could see that there was like those water droplets forming on the outside of the can. That's condensation. It's going from a gas to a liquid. Water. Water goes from a gas to a liquid. This means that and you would know this if you were like focused upon all the stuff we did in that lab, the relative humidity is 100%. Means also just a vocab word for what that means, that air is saturated. So as a result of all this, I guess I can number it 6, but it's really like 4, 5, and 6 are really kind of simultaneously happening. Form. Okay. And you'll tend to get, as they continue to go up and up and up, you'll get rain. This is what rain looks like in a cami dock. Okay. So that happens pretty much every time the air is rising. And that's what the lab is going to be. Let's look at the island of Hawaii topographically with a topographic map that you guys are going to draw, and then see what side of that island, if this like hand is the nub of my island, when the wind comes at it and it goes up, that should be the rainy side. And then the other side will be dry. We'll talk about that in just a moment here. What I want to do is split my diagram in half so we can talk about the two separate sides of the mountain. I'll zoom back out a little bit. Beautiful. So this side of the mountain is called the windward side. To the wind, windward side. And the windward side is what? What's that? All right, so then the air comes up the mountain. Now it's going to sink back down. If you understand this process, all you got to do is do it backwards the other way. If when air rises, it expands, what happens when air sinks? I don't know why these Cami boxes like to auto format. Sorry for the delays there. So air sinks. Oh, if when air rises, it expands. When air sinks, it compresses. Which means the air warms on the way down the hill. Um, this is where it gets a little bit harder. You really had to get the point of the questions on that humidity lab that have to do with the temp and dew points get farther apart numerically. What did that mean when they got further apart? Like on the graph question, which I'm going to do a review video on because it's okay. People didn't do great on it. But the idea was when those two lines got further and further and further apart, the temperature and dew point lines, it was getting drier and drier and drier when they got closer and closer and closer together. In fact, when they touched, that should have been when there was condensation happening. Or I think that question was asking about snow. But the temperature and dew point are getting further and further apart. It's actually getting down here. You get a warm, dry wind. It comes down the leeward side of mountains. Leeward. Leeward is fine. I said that for years until I got into sailing, and then all the sailors say leeward. I'm not sure there's a correct way. It's like one of those either way is fine kind of things. So this leeward side of the mountain, the out of the wind side of the mountain, and that we use that term in sailing too. You got the windward side of the boat where the wind's coming at you, the leeward side of the boat, opposite the direction of the wind. So these two terms aren't exclusive to this little process. Um, what else? So this warm, dry wind, the Native Americans knew about this because they were tracking buffalo, and the buffalo kind of innately, naturally knew about this, instinctively knew about this. So we're gonna draw a buffalo here. So before we, while the Native Americans still basically had reign of North America when there was no cities and roads and fences and subdivisions that keep the buffalo from migrating back and forth across the whole of the Great Plains. This is what would happen: is that in springtime they would come out here to this slope of the mountains because this warm, dry wind would be the first place where the snow would evaporate. So I won't leave that as a note. So the snow would evaporate here. Buffalo would come in. That's where they eat the grass, and then the rest of the season they migrate back across the plains. So Native Americans that track buffalo would travel along with them, understanding that. So there's a Native American word for this warm, dry wind that comes down the leeward side of mountains. It's called the Chinook. I don't suspect that would ever be on a test or anything. That's kind of like if you're ever on Jeopardy one day. There you go. Okay. This whole thing as a whole, it's the name of the file too. I mean, so you'll see it there, but this whole thing is called the orographic effect. The root of that oro has to do with anything that has to do with mountains. And orogeny is a period of geologic mountain building. We'll do those later. So yeah, what do you think? All right, so you this weekend, in between the time of me taping this and the time of me teaching this on Monday, will likely have experienced this. So what we've got right here, this area right there is the Tug Hill Plateau. You got Boonville and Melville over here in this, I think they call it the Snake River Valley. So there's a valley right here. You've got where we live over here on the plains, like Pulaski to Sandy Creek, up towards Watertown, all pretty flat all the way around this. And then this thing, the Tug Hill Plateau, goes up. by hundreds of feet. So what happens very consistently, very predictably, and I mean, this thing's big enough you can like you can't see out my windows, but go over to Mr. Archer's room and you can look out the windows and you can see the Tug Hill Plateau. It's that big prominence that's there. If you're boating at all over here, you just get away from the land a little bit, you can look over and see it. So what happens is the water, well, adds moisture to the air, right? That air is coming over the lake and it comes over Pulaski. And then as soon as it gets to like right here, this ridge, it lifts up and this turns into a giant like natural snowmaking machine. And it's exactly the orographic effect. It's exactly all that stuff that you just wrote down that creates an outrageous amount of snowfall right up here. Now the downside isn't really enough to get like the warm dry wind thing happening on the back over here. Plus then you got the Adirondacks to contend with, so you're going to go right back up again. But to a degree, it makes Snow Ridge, which is over here somewhere on this backside of the mountain, one of the snowiest ski places in the east. Yeah, they don't have a ton of elevation because the Tug Hill's only so big, but a ton of snow. All right, so current predictions is not going to be like, I mean, we're all used to worse than this, right? Thought I got it out at some point. Yeah, it's right there. Current predictions have that 6 to 8 up there, and if you're picking up what I'm trying to lay down here, as air comes over that lake, lake effect snow is kind of a thing because the air that comes over the lake is very cold. Here's where we go way back to energy. That lake stays warm in the winter because remember, water heats and cools really slowly. It has a high specific heat, so it dumps heat into that lake all summer long. That lake holds on to it. That cool wind comes over it, and since that lake is warmer, I mean, if you look at it, you wouldn't use a warm lake by any stretch, right? But it's warmer than the cold, dry Canadian air coming out of the north. Um, it sends a whole bunch of moisture up into that air, and then it comes here and immediately, I mean, this is a very short distance, immediately hits a big landmass, goes up several hundred feet, and dumps lake effects. Okay, so I'm not making this stuff up. It's really a thing. Um, how long am I getting? Should I skip talking about Ireland? Briefly, when I went to Ireland, about your age, maybe this was my second trip. Anyway, when I went to Ireland when I was younger, up in the northwest outside of Sligo, there's these giant rock formations, Ben Bulben being kind of the biggest and most famous of them. And it happens that these are not giant. I mean, they're not as big as the Tug Hill Plateau by any stretch. They're pretty small. I mean, they're big if you stand there next to it. You're like, holy cow! But I watched on a day where over here it was not raining. Clouds would form right about there. Air would come up, rise, hit that dew point, condensation, and form clouds. And the very top of the mountain was completely enveloped in clouds and rain. And then over here, as the air sank, the clouds dissipated. So this was like a cloud making machine and a rain making machine. It was raining only on the very top of this little plateau and nowhere else. All those like little valleys too indicate that there's a lot of rain, a lot of erosion. So again, this is a real thing. I'm not making it up. So your job is going to be in the lab. Then I'll do a separate video for the lab when I'm done listening to those tunes. I'll do a separate video for the lab where we talk about exactly what you got to do procedure wise. But the premise is to take a mountain, see what happens as the air comes up, plot out where there's a lot of rain, plot out where it's a little bit more dry, figure out where the mountains are. Sound good? All right, folks. We will see you. Happy 4-day weekend. We'll see you on Tuesday. When in reality, that's when you're probably watching this from underneath the snow. Take it easy.